Hi, it's time for another math easy solution. Here to discuss further into integrals and areas between curves, and now look at when we deal with basic functions of y, or we rewrite the regular y equals f of x functions, etc., as functions of y. So from my earlier videos, I solved the area between curves bounded by writing the curve as functions of x, such as this one. Y equals fx is y equals g of x. So say you had to get the area between this region, let's call this this x equals a, and this is basically x equals b. Yeah, and we wanted to get basically this region right here between this x equals a and x equals b, and this y equals fx, and this is y equals g of x, and then basically the area, this a right here, this area is equal to, I show base integral from from a to b, let's write this better, of basically f of x minus g of x and then dx. Yeah, but sometimes it is best to treat the regions by regarding x as a function of y, and I'll do an example in a later video. Yeah, so for example, if you had function such that looks something like this, and we want to find the region between, let's say, this right over here, and as you can see, it's easier to write this as a function of y, so we would basically write this one right here as x equaling 2 g of x, g of actually let's call this f of y right here, just because this is, when we look at the y one, imagine this was flipped, and then the top one, let's write that as f, and this is x equals g of y. And now this line right here would be y equals, let's call this b, and this right here is y equals a. So now we would basically write this function. It's the same thing, but we just changed our variables. So now we'll have the area. Let's go a equals 2 integral from a to b. Yeah, of now this is going to be f of y minus g of y, and then dy right here. So basically, when we look at this right here, if we were to break it up into rectangles, infinite rectangles would be something like horizontal one right here, and this would be our delta y, or infinitely small as dy right here. And actually, instead of a and b, we'll just write it as c and d, just to show, just make it look different from our old. Yeah, it's called c and a. Just change a variable just to make this a and b. This is going to be the switch right there. And yeah, and it means the same thing, isn't it? It's not just, they're just letters. Yeah, but sometimes it's just easier to write the functions as xr and xl, indicating left and right, as I will explain in my next video on an example on this. Basically, if we had something like this, and this is from, again, d, call this y, this is x, and let's say it's something like this, and this is let's call this c, this is a region like this. We'll call this one, it's easier to see it, as xr, and this as xl. Yeah, and once again, these are basically functions of y right here, both of these. This would be f of y, this would be, I guess, g of y, and then when we write it out, it will look something like a equals 2 from c d xr minus xl, and then this is going to be dy. And that dy is going to be a horizontal rectangle when we look at it in terms of just rectangles. So, and again, it's the same thing. This is the same thing as regular one, but everything is just flipped over by 90 degrees. Anyways, that's all for today. If you learned from this quick video, well, I'll do some examples on this in later videos, so stay tuned for that. They'll be pretty useful. Anyways, that's all for today. Like always, you can download these exact notes in the link below, and thanks for watching, and stay tuned for another math easy solution.